Today in this class I am going to discuss about the balance condition of Wheatstone Bridge. Here the schematic diagram of Wheatstone Bridge is given. PQRS are the resistances of this Wheatstone Bridge and they are connected in series. Here the point is A, this point is B, this point is C and this point is D, and we consider the potential at point A is VA, the potential at point B is VB, the potential at point C is VC and the potential at point D is VD. Okay, now at the two ends of A and C, the cell and the key are connected, and at the opposite end of B and D, a galvanometer of resistance capital G is connected. When we switch on this key, then the main current flows from the cell and it comes at point A. When it comes at point A, it divided into two paths. One is along AB and another is along AD. We consider that along AB the current is I1 and along AD the current is I2. Here the potential at point A is greater than at point B, and the potential at point B is greater than at point D, and the potential at point D is greater than at point C. That's why when the current I reach at point B, it again divided into two paths. One is along B to D and another is along B to C, because we know that the current flows always the higher potential to lower potential. Here the current is IG and along BC the current is I3. When the current IG reach at point D, at the same time the current I2 reach at point D and they mix together and makes the current I4 which flows from D to C. Again, when I4 reach at point C, then current I3 meets with I4 and makes the main current I, and this main current again come back the cell. This is the current distributions of the circuit. Now I am going to discuss about the equation of the circuit. First we consider the point B, and we have to apply here the Kirchhoff's junction law. So at point B, using the Kirchhoff junction law, what we get? Here we are getting that I1 is incoming current, IG is outgoing current, I3 is outgoing current. That's why according to junction's law, we get I1 minus IG minus I3 equals to 0. When the potential at point B and at point D are same, then the bridge will be in balance. Okay, when the potential at point B, that is VB, equals to VD, then the potential difference between B and D will be 0. And we know if the potential difference is 0, then no current will flow through the line. That's why in this case the IG will be 0. This is called the balance position or the null position of the Wheatstone Bridge. Okay, now using IG equals to 0, we get from the above equation I1 equals to I3. We consider this equation is 1. Again, if we use the Kirchhoff junctions law at point D, we get that at D, here I2 is incoming current, IZ is incoming current and I4 is outgoing current. That's why we can write here I2 plus IG minus I4 equals to 0. But here IG is 0, therefore we get here I2 equals to I4. This is equation 2. Now we have to use the Kirchhoff's loop law or voltage law. Here A, B, D, A is a closed loop. So using here the loop law at A, B, D, A, we are considering the current is flowing along the clockwise. We also can take the current flows along anti-clockwise. It is our wish. Now here I am considering the direction of current is along clockwise. That's why according to Loop's law here, I1 P plus IZ Z minus. Why it is minus? Because I2 is anti-clockwise, while I1 and IZ are clockwise. That's why here I have to use the minus sign. I2 R equals to 0. But according to null position, IZ is 0. That's why from it we can write I1P equals to I2 R. This is equation number 3. Again, at the right side there is another loop. This loop is B, C, D, B. Okay, here we get another closed loop, that is B, C, D, B. Here we are again can use the Kirchhoff's Loop's law and get I3 Q minus I4 S minus IG G equals to 0. Here I4 and IZ are anti-clockwise. That's why here we used the minus sign. As IG is 0, we get from the above equation I3Q equals to I4S. We consider this is equation number 4. Now if we divide equation 3 by equation 4, we get that equation 3 by equation 4, we get 1P divided by I3Q equals to I2R divided by I4S. Okay, now according to equation 1, I1 is equals to I3. So we can write next I3P divided by I3Q equals to, again according to equation 2, I2 is equals to I4. That's why here we can write I4 instead of I2 R I4R. So from the above equation finally we get P by Q equals to R by S. This is called the ratio of P by Q equals to R by S is called the equilibrium condition of Wheatstone Bridge or balance condition of Wheatstone Bridge. Hope you got it.
The video and its content is subjected to copyright. Convention of this video elsewhere is a punishable offense. Any redistribution or reproduction of part or all of the contents in any form is prohibited. You may not issue or commercially exploit the content, nor you may transmit, duplicate, publicly display, or make derivatives of this video. The video is protected by intellectual property claims to stimulate and ensure originality. All rights reserved by Adamjing Cantonment College.